All right, hello and welcome. So in this video, we're going to be looking at what's called Gaussian elimination. Um, and so basically what we're going to be doing is kind of showing you what your calculator is doing when it's simplifying those matrices down in order to solve for the systems of equations. So the example that we're going to work through is this system right here. So we've got 3x minus y plus z equal to 1, 2x plus 3y plus z equal to 4, and then 5x plus 4y plus 2z equal to 5. So here that system is rewritten as a matrix. Once again, I've labeled my x, y, z, and then my final numbers so we can make sure everything is lined up correctly. And then from here, what we're going to do is manipulate the numbers in the matrix to basically simplify it down into a point where we can solve it using the methods we actually looked at from the first part of this unit. So what we're going to focus on is canceling out these three numbers right here. So if I can cancel all of those numbers to get 0, then I can solve the equation using substitution like we did in Unit 3, Part 1. And so the way that we're going to do that is by distributing numbers to each row and then adding or subtracting the numbers in the rows to get things to cancel out. So I'm going to focus on this guy right here first. So the key is that we can only eliminate one number at a time. And if I can get this guy to go away first, then I can start to worry about the one above it and then the one next to it. So in order to make the 5 cancel out, I first need to make like two matching numbers right next to each other. So to do that, I'm going to multiply the second row by 5 and the third row by -2. So let's distribute those values and see what we get. So if I take 5 times 2, that'll give me a 10. If I take 5 times 3, that will give me 15. And if I take 5 times 1, that'll give me 5. And then 5 times 4 will give me 20. On the bottom row, I'm going to take -2 times 5 to give me -10. -2 times 4 to give me -8. -2 times 2 to give me -4. And then finally, -2 times 5 to give me -10. So when I look at it again, now these two guys will cancel out. So the next thing I'm going to do is combine row 2 and row 3. And so whenever I'm combining, I'll usually just want to try to do one row at a time. So I'm going to replace the bottom row with the numbers combined together or added together. So 10 and negative 10 cancel out to 0. 15 minus 8 gives me 7. 5 minus 4 gives me 1. And then 20 minus 10 gives me 10. And so looking at it now, my 0 here has canceled out. So if I want to cancel the 10, then what I'm going to do is try to make these two match. So I want to multiply 10 to row 1 and negative 3 to row 2. So 10 times 3 becomes 30. 10 times negative 1 is negative 10. 10 times 1 is 10. And then we get another 10 as the last number. On the second row, I'm going to do negative 3 times negative 10 to get negative 30. I'm going to do negative 3 times 15 to get negative 45. I'm going to do negative 3 times 5 to get negative 15. And then negative 3 times 20 to get negative 60. So now I should be able to combine these two guys to get that second 30 to cancel out. So in the middle, I will do row 1 plus row 2. So 30 minus 30 gives me 0. Negative 45 minus 10 is negative 55. 10 minus 15 gives me negative 5. And then 10 minus 60 gives me negative 50. So the last thing I need to do is get rid of this 7 right here. So I could do this by multiplying 55 to the bottom row and 7 to the top row. But I don't like working with such big numbers. So before I do that, I notice that everything in the middle divides by 5. So my first step is going to be to divide row 2 by 5. So that would turn 55 into 11, 5 into 1, and then 50 into 10. So then now when I try to cancel the 7, my numbers are a bit smaller. So we're going to take row 2 times 7 and row 3 times 11. Notice since I already have negatives in the middle, I don't need to multiply by a negative on either row because my signs are already opposite. So we'll do 7 times 11 to get 77. 7 times 1 to get 7, and then 7 times 10 to get 70. On the bottom row, we'll do 7 times 11 to get 77. 1 times 11 to get 11. And then 10 times 11 to get 110. And so now my final step is to combine these two to get that 77 to cancel out so that I have zeros in the bottom left corner. So I'm going to take row 2 plus row 3 and put that new answer on the bottom row. So if I do negative 77 plus 77, I get 0. If I do negative 7 plus 11, that gives me 4. And then if I do negative 70 plus 110, that gives me 40. So at this point, we have all of the zeros where we want them. So this next step that I'm going to do is technically optional, but I'm going to divide the different rows by common factors that I see to make the number smaller. This is something that you don't need to do. It's just helpful for where the simplification comes from. So I'm going to divide everything in the top row by 10, everything in the middle row by negative 7, and then everything in the bottom row by 4. So 30 divided by 10 would be 3. Negative 10 divided by 10 will be 1. 10 divided by 10 is 1. Same thing here. So when I divide negative 77, it just becomes 11. When I divide this one, it just becomes a 1. And then negative 70 divided by negative 7 will just be a 10. And then finally, 4 by 4 divides to 1. And then 40 and 4 divides to 10. So the last step that we're going to do is take the numbers in our simplified matrix and put them back into an equation. So you can solve it using substitution like we did in part 1 of this unit. So I should see 3x minus 1y plus 1z equal to 1, 11y plus 1z equal to 10, and then 1z equal to 10. And so from here, you would plug in using the bottom row and then solve for y, and then plug in again, just like we did in the first section of the unit. That's all I have for this one. I will see you guys next time.